So can guys, you can download, you can explore our courses at Value Point. You can purchase this course of Erodo series, and it is very cheaper rate. You can see in our platform www.valueedgepoint.com. Okay, guys. So this is very helpful. Okay, you can visit our this site. You can purchase it here, or you can download our app from Google Play Store. Okay, or iStore. So you can start your preparation. Doesn't matter you are in ninth, you are in 10th, you are in 11th. Okay, guys, if you want to ensure your selection along with 12th, you can start your preparation with us, guys. We are providing quality full content for JEE and NEET and other state and national examination. If you want to professional after 12th just passing out, you can purchase our courses and you can start your preparation, guys. Okay, so today we are starting our Erodo series. This is the first question of Erodo series. You can see here, guys. Okay, you can see here. This is the first question, a motorboard. So first of all, to start the Rodo series, guys, this is the very, if you have deep understanding of physics, then you can solve these questions. Otherwise, first go through my video lectures of JEE or NEET, then attempt this book. Okay, then try to attempt this book. This will be very helpful. If you direct try these books, then you have to face some difficulties. Otherwise it is very easy after attempting, after you have some sufficient knowledge of subject. Okay, so we are starting the first part, kinematics, and this is the first question. A motorboat going downstream overcome a raft at a point A. Okay, and it takes 20 minutes, 60 minutes. Later, it turns back after some time pass the raft at a distance 6 meters from the point A. Find the flow velocity assuming the duty of the engine to be constant. It means the velocity, okay, it means it try to make velocity constant. Okay, the role of this, the meaning of this line, but this is not so important for us. We are direct approaching this equation. Okay, guys, so what is happening? Okay, suppose that this is the river. Okay, this is the river. Okay, so or we assume that the flow velocity of the river, we can assume, okay, the flow velocity of the river, that is v naught. Okay, the flow velocity of the river, we can assume that is v naught. Okay, and we are assuming the velocity of motorboat. Okay, we are assuming the velocity of motorboat. Okay, the velocity of motorboat, with respect to the velocity of motorboat with respect to ground. Okay, that is equals to v. Okay, that is equals to v. Okay, v unit. Okay, guys, so now what is happening here? Some raft is here. Okay, suppose that this is the raft. This is the raft, and this is the point A. Assume this is the point A, guys. If you know the basic geometry, then you can easily solve these questions. Otherwise, you have to face problems, guys. Okay, this is the point A. Okay, this is the point A. At this point, this motorboat. Suppose that this is a motorboat. Okay, this motorboat going in this direction. Okay, so and okay, the motorboat moves some direction. Okay, moves some direction. Okay, so motorboat comes here. Motorboat comes here. Okay, the motorboat comes here, and the time taken to cover this distance, that is 2. Okay, when this motorboat again start, Okay, in this direction moving, so raft will come here. Suppose that raft will come here, and the distance traveled by the raft from here to here, that is L distance. Okay, that is L distance. Okay, so now this point is B. This point is B. Okay, so now clearly look this, guys. Then this sorry, at this point again, at this point again, the motorboat crosses raft. Okay, and that is L distance from the point A. Okay, so the while returning the distance covered by the motorboat, that is equals to this distance. Okay, that is equals to this distance. Is it okay, guys? Okay, we assume this distance is x. So now what the question is asking, we can make a relations. Okay, and we have to find out the flow velocity. Okay, the flow velocity is the v naught. We have to find out this velocity. So now what we have to do in this question, we have to make relation between two. So that see what is the approach to solve this question. So the time taken by raft from A to B is equals to time taken by motorboat taken by, sorry guys, here not two times, twice times is coming, not here time, that taken will come, time taken, here also time taken by motorboat. Okay, time taken by motorboat from A to, from A to B, and the time taken by raft. Okay, time taken by raft, that is, and the velocity of raft, again the velocity of the raft is slowing very moving very slowly, so we assume the velocity of raft will be equals to the flow velocity. Is it okay, guys? So the time taken by raft from A to B, that will be equals to the length and velocity. Is it okay, guys? And the time taken by the motorboat from A to B. Okay, so motorboat going first in this direction, then coming in this direction. So guys, you can see the motorboat journey will be in such a way. Okay, first motorboat going from here to here. It travels, he travels some distance. Okay, he travels some distance, and again he come in this direction. Is it okay, guys? Again he comes in this direction. Right or wrong? Okay, up to this point. This is the B point. Okay, this is the B point. This is the B point. Okay, or we can draw. Okay, we can draw in such a way that you can easily understand. This is the B point. Okay, guys, this is the B point. Okay, this is the cross section of B point. Okay, so you can clearly see this distance. First, it will take toe time from the motor road will take from it here to here. We can say this point is C point. Okay, so A to C. Okay, that time taken will be toe, and the again the distance covered by motorboat, that is x. The time taken is distance upon velocity. Now guys, that is very important. When motorboat will flow motorboat its own velocity, that is v. Okay, so when in downward, in case of downward, okay, means when motorboat go inside, the downward velocity, okay, of motorboat with respect to water or stream, that will be v plus p naught. Okay, or when in case of upstream, in case of upstream, velocity of motorboat, remember guys, this is the velocity of motorboat, but with respect to water. Okay, that will be v minus v naught, guys. So here the distance is x and the velocity, that will become relative velocity, that is v minus v naught. Now we have to calculate the x. Okay, this is our equation number first. Now what, how we can calculate x? See guys, look at this very carefully, very carefully. Okay, it is very good question. Erodo all problems is very good. Now see how we calculate x. So x you can see, now. Okay, we can calculate this distance. That will be, the distance is equals to velocity into time, and the motorboat velocity in downward direction, that is v plus v naught, and the time is. So, okay, the total distance, and if I minus the L distance from this distance, then x will come automatically. Okay, or we can say x is equals to, we can say x is equals to AC minus AB. So AC, this is the distance traveled by motorboat. So velocity into time, there is no problem. Distance equals to velocity into time, and the AB we know L. Okay. So simply we put in this formula. This is the equation one and equation two. We replace the equation number one. Okay, that is V naught upon. Okay, the time we sorry, the time will be L naught upon V naught. Okay, what question is saying? Okay, first read the question 2 3 times. This is the our basic fundamental principle. Okay, so it is simply saying, when a motorboat going downstream overcome a raft at point A, 60 meters later he turned back and after some times passed the raft at a distance point A. So guys, this is the equation one. This is the and the other is equation number two. So now we compare. We replace the value of x. Okay, L upon V naught. Okay, L upon V naught. L upon V naught upon L upon V naught is equals to tau plus x. We have calculate x V naught V. Sorry, this is the V. Okay, V plus V naught into tau minus L upon the velocity, that will be V minus V naught. Okay, guys. Further we solve it. Okay, we take L upon V naught, or if I divide by this denominator, I split these two terms in this way. See guys, tau plus V naught plus V upon V minus V naught upon tau minus L upon V minus V naught. Okay, so come along. We if we transfer in this side, then this will come V minus V naught. And if I take tau common, and if I take LCM, so LCM will come V minus V naught. Is it okay, guys? So here coming V minus V naught plus V plus V naught. Here V naught cancel out. Is it okay, guys? And if further solve this, if you take L, here is common, then if you take LCM, so V naught, V minus V naught. Okay. Here V minus V naught will come. Here V naught will come. Again here you can see. So here 2 V tau upon V minus V naught. And when you further solve it, okay, when you further solve it, here V naught is cancelled. Okay, when you further solve it, or here you can see denominator, this is again same. So again, this will be cancel out. Agar here V is only remaining, so this V also, okay, this V also cancel out from this V. So you can see the V naught is equals to L upon 2 tau. Is it okay, guys? So when you put the values, okay, that is given in the question, always in Erodo try to solve in, and okay, in variable form. Okay, or in the last expression put the values. So L is given 6 kilometer and tau is given 60 minute. Is it okay, guys? L is given 6 kilometer and tau is equals to 60 minute. Okay, guys. So L 6 kilometer and tau is 60 minute. Okay, so this is the kilometer we can convert into meter, or minute we can convert into second, that will be into 60. Okay, so guys, if you further solve it, okay, this 10 will come, or here 100, 1 1. Okay, so if you try 3, this is 5. Okay, so it will comes out to be 5 by 3 meter per second. Okay guys, this is our, this is the stream velocity. Is it okay guys? So without delaying, we are going our next question. Very good. Erodo is problem is very good problem, guys. Very good problem. So now we are going to our second question. A point traversed half the distance with a velocity v, and the remaining part of the distance was covered with the velocity v1 for half that time, with velocity v2 for the other half of the time. Okay, find the mean velocity of the point averaged over the whole time of motion. So what happening, guys? Look at this. What is happening? Okay, this is the time journey. We can make okay, this is the time journey. So what is happening here? The half distance, that is, we can say that is L by 2, and this the again, this is the L by 2. Is it okay guys? So now half the distance with the velocity v, and the other remaining part the with the velocity 1. Okay, and a point traversed half the distance with a velocity v naught, and the remaining part of the distance was covered with the velocity v1 for half the time. Now guys, look at this. The question is saying in the first, the point traversed half the distance with the velocity v naught, and the remaining part of the distance was covered with velocity v1 for half the time. Okay, so guys, what is saying for half the time? The remaining distance for half the time with covered with velocity v1. Okay, and the remaining of the time velocity v2. So what we are doing, guys, we are taking the time taken in this portion, that is 2, and the time will be same for these two portions. So we are assuming the total time in this journey will be 2t. Okay, we are assuming 2t, and this is the t. Okay, or we can say the time taken t, the time taken t here is 2t. Is it okay guys? Now the distance, that is L by 2, is equals to, for this portion we know distance is the velocity into time, and for the next portion, okay, for this portion, okay, we can say this is the A, this is the B, this is the C, this is the 4 AB, this is the 4 BC. So L by 2, that is equals to V1 T plus, sorry, not V not here, V1 will come. Okay guys, here v1 will come. Okay, v1t plus v2t. Okay, we can write down again L by 2, v1 plus v2 into t. Is it okay guys? Is it okay? Now what we have to do, the find mean velocity. We know the formula of mean velocity, that is equals to total distance upon, guys, that is equals to total distance upon total time. The total distance, that is equals to L, and the total time, the total time. Okay, so the total time, that is 2t plus 2t. So 2 plus 2t. This is the total time. Okay, guys. So here you can calculate the here you can calculate the value tau. So guys, you can calculate here tau. Okay, here tau, that is equals to, tau is equals to L upon 2 V naught. Or here you can guys calculate T. Okay, that T is equals to L upon 2 V1 plus V2. Is it okay guys? Put this value simply here. So now guys, we are putting the value in this expression, that is average velocity is equals to L upon the value of tau we have already find out from here. So we can directly write down L upon 2 V naught. Okay guys, and the value of t we already know this expression. So that will comes out to be 2 already here, and that is L upon 2 V1 plus V2. Is it okay, guys? Here 2 is 2 cancel out. So now guys, again we okay. Next we solve this expression. Okay, guys, look at this. We solve here. Okay, the average velocity that is equals to L is already here, and we take L common here. Okay, and the bottom side, the denominator, we take LCM. That will comes out to be 2 V naught V1 plus V2. Is it okay, guys? Or here V1 plus V2, or here 2 will not will come. Here L is L cancel out. So the average velocity will comes out to be uh, 2 V naught V1 plus V2 upon V1 plus V2 plus 2 V naught. Is it okay, guys? This is the expression of average velocity. So this is the simple problem, but you have no idea, your concept is weak, then you have to face problems. Otherwise, it is very easy problems. Okay, guys. For the next question. Okay, this is question number third. Again, this is the very easy question. Okay, guys. Again, this is the very easy question. When you know the concept, you can easily solve the problems. Otherwise, you have to face problems. Wow, question. What is question number is saying? Question number 30 is saying a car starts moving rectilinearly. First, with acceleration omega, that is 5 meter per second square, the initial velocity equals to 0. The uniformly and finally decelerating at a same rate omega comes to a stop. The total time of motion equals to t is equals to tau is equals to 25 seconds. And the average velocity during that time is equals to 72 per hour 72 kilometer per hour. How long does the car move uniformly? So how long we have to calculate the time and also distance. So look at this, guys, how we approach this question. So first of all, we convert this data, the average velocity 72 kilometer per hour. We will convert this value into meter per second. That is, we divide 5 multiply 5 by 18. Okay, this will come 4 times and 20 meter per second. This is the our average velocity. Is it okay, guys? And now what is happening here? So rectilinearly one body is going. Okay, one body is going. Okay, so what is happening here? See, guys. Okay, in this version, see, guys. Okay, we make one graph. What is happening here? So, guys, first body start from 0. He accelerate with the acceleration omega, then uniformly moves, then again comes into then decelerate, then comes into rest, and the rate is equals to same, that is omega. This is omega, this is omega deceleration. Now what is happening here? See, look at this, guys. This is the vt curve. Okay, so if you know, if you perfect in graph making vt curve in kinematics, then that is very helpful to solve the problems. Otherwise it is very difficult. So now, guys, what is saying in the question? Okay, in the question, what he's saying, in the question, what he's saying, first, look at this, guys. Okay, uh, is it okay? Now, look at this very carefully. Okay, the total time of motion equals to tau. Okay, we are assuming. Okay, the time taken, we are assuming it is given the total time. The total time is taken, that is tau, to cover this. Okay, and this is the time, or this is the velocity. On y-axis this is the velocity, on axis this is the time, and this time is, that is tau, this is 0. Okay, so guys, I am assuming the time taken to achieve the maximum velocity here. Here velocity will be maximum. Okay, and we can calculate the maximum velocity, initial velocity 0, that is omega t, and the time t that will comes out to be here. So what I am taking the uniformly covered distance, I am assuming the distance covered in this portion, okay, sorry, the time taken in this portion, that is delta t, okay. So this time, okay, this time will be half, this is the same area because the acceleration rate is same, so the slope will be same, okay. So slope is same, so the whole from geometric properties, the whole triangle will be same. The time taken in this portion, that will be this plus this, okay. So I am taking the time taken, that is delta t, or t minus delta t, okay. Tau minus delta t, that will be time from to cover this distance, and for this distance, this will becomes to be half. Okay, guys. So the time cover from here to here, we can numbering O A B C. From O A, so that time will be tau minus delta t by 2. Again, this time same, tau minus delta t by 2. Is it okay, guys? So here omega t, the time will become here t minus delta t by 2. Okay, guys. So now again we are coming the average velocity formula, that is total distance upon total time upon total time. Okay, so this is the average velocity. Now the total time we know, that is tau. So average velocity multiplied tau, that is total distance. Suppose that this is the total distance, area under VT curve, area under VT curve. Okay, so I'm saying this is the area A1, this is the area 2, this is the area 3. If you add these three areas, we can get the total distance. Is it okay, guys? So area 1, area 1, that is equals to the triangle half into base is time t minus delta t divided by 2, and height is Vmax, and the value of Vmax, that is omega t minus delta t by 2, okay. And the again, the velocity in this portion, that is Vmax, uniformly moving, so that is again omega velocity, omega tau minus delta t by 2. This is the velocity, guys, Vmax, and the time, that is delta t, okay. And for the third portion will be same this portion, so I'm directly write down omega by 2. Or in some students, one question will ask, this is the decelerating, so minus omega will come. But remember this, guys, when we are calculating distance, so we take modulus of these areas. So I am writing directly omega by 2, or t minus delta t by 2 whole square, okay. Okay, guys. So look at this. Now here I am writing this portion, okay. Here I am writing this portion. Now finally we got omega average velocity into tau, and this, okay, if I take this will be double, okay, and this half, okay, this will be double, and I can write down, okay, I am writing down this portion, that is omega t minus delta t upon tau minus delta t by 2 whole square, okay, plus omega t minus delta t by 2, sorry, into delta t. Is it okay, guys? You can look at this, we are going right or wrong. If you add this omega by 2, this will become double, okay. So omega t minus delta t tau square, or in this portion omega t minus delta t by 2 vt vmax into t, this is the, okay. So we are going right, okay. Now we will solve this portion. Okay, so how we'll solve it? Simply what we have to do, we will take this tau minus delta t by 2 common plus omega we are taking outside. So in this t minus delta t by 2, or in outside, that is delta t is inside. Okay, if we are taking this portion common, so omega tau minus delta t by 2. Now we take LCM, we solve it. Okay, tau minus delta t plus tau t. Is it okay, guys? When you further solve it, so this is omega. Okay, sorry, this is omega, guys, or here tau minus delta t by 2. Here, when you solve this, so tau minus delta t, this is the 2 delta t. Okay, this is the 2 delta t. So 2 delta t minus 1 delta t, that is plus 2 plus delta t divided by 2. So you can, guys, a minus b, a plus b, you are seeing clearly. So here the average velocity into total time tau and omega square, omega by 4, or here tau square minus delta t square. Is it okay, guys? Now we have to calculate delta t square. Okay, guys. So what I am writing here, you can see I am writing here 4 average velocity upon into tau upon omega, and tau square minus delta t square. So now what we have to do, guys, this is delta t square, that will be okay. I'm directly write down the delta t, which is equals to the under root of, okay, the under root of tau square minus 4 average velocity into total time, and this is omega. Okay, guys, when you put this value, so we know that time is total time is given. Okay, the total time is given, that is 25 second. Okay, guys, the total time is given, that is 25 second. Is it okay, guys? The total time is given, that is 25 second. Is it okay, guys? 25 second. Okay, and this is 4, and the value average velocity 20, and that again 25, and the omega is 5. Okay, you can see the value of omega here, the acceleration, that is 5 meter per second square. Is it okay, guys? Okay, and when you solve this, expression, okay, so delta t will comes out to be delta t, which equals to 15 second. When you solve, okay, solve, delta t will comes out to be 15 second, and the distance will be covered uniformly, that is v max into delta t. Okay, v max we know the omega value 5, and total time, that is 25 seconds, and delta t, that is 15 divided by 2. This omega t v max, and the time is 15. Okay, and this will comes out to be 375 meter. Okay, guys, this is the distance covered in this journey. Okay, guys, now we are going for next question. Is it okay, guys? So this is the very simple question. Okay, again, this is st curve. St curve is given. Okay, and the slope of st curve, that will gives to the velocity. Okay, so first question is asking the average velocity. Okay, guys, the average velocity. So remember, whenever you ask average velocity, join these 2 points. Okay, first initial point to last point. Okay, this gives the average velocity. Okay, guys, this gives the average velocity. This is the average velocity, v average. Okay, so we can calculate v average. That is, if you look at this triangle, Okay, from 0 to here. Okay, 20 second, and this is the height. Okay, if you look at this triangle, that is slope, average velocity is slope, that is tan theta, and that tan theta will comes out to be, this is the height, that is 2 meter. If I convert into centimeter, we multiply 100 and divide by time. Okay, so 10 centimeter per second, this is the average velocity. Next question is asking maximum velocity. So now very slow with maximum. Okay guys, very slow with maximum. Look at this in this portion. Okay guys, in this portion, if I change the color, you can clearly visible. Okay, in this portion guys, in this portion you can clearly see, in this portion the velocity is maximum, the velocity is constant also maximum. So we focus on this triangle. Okay, so this point is equal approximately 14. Okay, and this is point 2, this is again 14. Is it okay guys? This is 10, so not 14 guys, this is the, this is 1, this is 1.2, this is 1.4. Okay, or this point that is equals to comes out to be point 0.2, this is point 0.4. Okay guys, so now the maximum velocity. Okay, the second part is maximum velocity. Okay, so now the maximum velocity is equals to this height. We have to calculate this tan theta. So the height is 1.4 minus zero point 0.4 divided by 14 minus 10. Okay guys, when you solve this, 1 upon 4 multiply by 125 meter per second. Okay guys, so the maximum velocity will comes out to be 25 meter per second. Is it okay guys? Now the third question is asking very good question. The time moment t naught at which the instantaneous velocity is equals to the mean velocity averaged over the first time t seconds. So for average velocity, mean velocity or average velocity over the first t naught ta seconds is equal. So now guys, whenever this equal problems comes, always remember on that point. So we have to find that point where instantaneous velocity. Okay, what is instantaneous velocity? See guys, if I'm talking about the instantaneous velocity at t equals to 8 seconds, so the slope at this point, tangent at this point will give the instantaneous velocity. So guys, for average first t naught ta seconds, what we have to do? Okay, similarly, you draw an tangent from 0 to here. Okay, here. This is the average velocity. Okay, and again draw a tangent such point where these lines exactly same overlap. Okay, exactly same overlap. So guys, you can see. Okay, you can see I change the color. You can easily see. Okay, guys, you can easily see. Look at this, guys. This point. Okay, at this point both the, this is the instantaneous velocity, the orange color, that is v instant. Okay, okay guys, and the black, that is v average. So both the air overlap each other, so this point, this velocity will be equal. So this point, when you drop in horizon on x time axis, this will comes to be 16 second. Okay guys, this will comes to be 16 second. So the answer is for third question, that is 16 second. Is it okay guys? Okay, the fourth question is completed. Okay guys, now we are going to our next question. Okay guys, we are going to our next question, that is question number 5th. Okay guys, we are going to next question hour, that is question number 5th. So look at this guys, this is the again very good problems. Okay, so two particles 1 and 2 moves with a constant velocity v1 and v2 and the initial moment their radii are equals to r1 r2. Okay, radius vectors. How much the four vectors be interrelated to the particles to collide. So now what is happening, guys? Look at this. Okay, we draw our Cartesian geometry portion. So, so two particles here, two particles, their velocity vector is given. Okay, the velocity vector is, sorry, position vector is r1 and r2. So now the particle starts in this. Suppose that the particles going in this direction. Again, the another particle is going in this direction. Okay, and they collide here. Look at this, guys. This is the particle A. This is the particle B. Okay, or they collide here. See, they collide here. Okay, guys, and this is the collide vector, that is r3. Okay, this is the r1, this is the r2, this is the r3, guys. And we know the distance travel from here to here, the time is t. Okay, we are assuming they are taking two time to collide from here to here, from here to here. So the velocity of particle 1, that is v1, and time is t, assume t, and the time is t2. To collide, to cover the distance bc, to cover the distance ac, particle 1 a will take t1 t time, and again particle b same time will take t. Okay, guys, now from triangular law, okay, triangular addition law. Okay, guys, you can see here. So this is the two vector. Okay, not triangular, parallelogram law, sorry. Okay, parallelogram. So this is the diagonal, or this is the two vector. Okay, guys. Sorry, guys, sorry for vector addition. From vector addition, two theorem is, one is triangular, then is parallelogram. So here one is head, another is tail. So this is triangular law. Okay, and the so this vector plus this vector will give the final vector r3, or resultant vector r3 is equals to r1 plus v1t. Is it okay, guys? And for the same, this triangle also, that will comes out to be r2 plus v2t, guys. Is it okay, guys? Is it okay? This is the vector quantity. So if I solve this, okay, if I solve this, I can write down r1 minus r2, that will equals to v2 minus v1 into t, that, and t is equals to r1 minus r2. T is scalar quantity, we have to take modulus of these two quantities. Is it okay, guys? Now again in this, okay, now again in this portion, I can write down the r1 vector is equals to r2 plus v2 t minus v1 vector. Is it okay, guys? v1 t vector. Is it okay? Now again what I'm writing, r1 minus r2, and I am taking v2 t common. Okay, and I am putting the t value t of in this equation, equation number 1. Okay, guys, so now what will come? Okay, what will come, guys? What will come? See, look at this here. What will come here? r1 minus r2, or v2 minus v1. Look at this, guys, v2 minus v1, v2 minus v1, and the time we have already calculated, that is time is r1 minus r2, modulus of r1 minus r2 divided by modulus of v2 minus v1. Okay, so uh, this is in multiply portion. So what I am doing, uh, okay, first take this portion into in this denominator upon the modulus r1 minus r2. Okay, here v2 minus v1, again v2 minus v1. So this is the relation between these two vectors. Okay, we can directly write down this. Okay, this is the vector and this is the magnitude. Okay, whenever you see this is the vector and this is the magnitude, this is the guy's unit vector. Okay, so I can write down this portion in this way: r12 unit vector is equals to v21 unit vector. This is the our solution of these problems, guys. Okay, it is very important result. Okay, so the relative distance, remember this, guys, this is the very important result. That is this is the very important result. Finally what we got. Okay, finally what we got, we acquired this result: r12 cap is equals to v21 cap. Okay, what is the mean of, what is the significant of this result? Okay, guys, what is the significant of this result? Okay, what is the significant of this result? Means the direction of relative velocity, direction of relative velocity. Okay, guys, what is the direction of relative velocity? Will be equals to their uh, their separation distance or relative distance in opposite direction. Okay, the relative distance will be in opposite direction. Okay, the relative distance will be the relative distance or separation distance or separation distance. Okay, will be in opposite direction. Okay, so what it means, guys, suppose that the relative direction in this direction, relative velocity in this direction, then their relative position will be in this direction. Okay, same. Okay, so this is the r12 cap or this is the v12 cap. Is it okay, guys? So now we are going to again our next problem, that is problem number problem number 6. Okay, guys, so it is very easy problem when you start solving this. Okay, this is the normal vector problems. Okay, so what is happening, guys? One ship moves along the equator. Okay, this is the equator. Okay, guys, this is the equator and one ship go in this direction. Okay, guys, and the southeastern wind blows at angle 60 degree, okay, to the equator. So we can say, okay, the wind is coming in this direction. Okay, 60 degree to the equator. Okay, with the velocity v, and or this is the velocity of v naught. Okay, the ship velocity. And what is happening next is the equator. Now find the velocity v dash relative to the ship. Okay, guys, so find the wind velocity. Okay, this is the wind velocity. So now what we have to do, we have to calculate v dash relative to the ship. Okay, so we can say v dash equals to v minus v naught. Okay, guys, and the angle phi dash between the equator and the wind direction in reference frame fixed to the ship. Okay, guys. So now we have to calculate v dash, that will equals to v minus v naught. We know v naught here, so v minus v naught in opposite direction. Is it okay, guys? Is it okay? And okay, is it okay? We can change the color so that you make sure you cannot don't confuse with this arrow. This is not v naught. This is the minus. This is the minus v naught. Is it okay, guys? This is the minus v naught. Okay, this is the v naught. Now, again, if I take this arrow in this direction forward, okay, okay. Sorry, guys. Sorry. And the direction between these two vectors, okay, okay, guys. So the angle between these two vectors, that is 60. Again, this vector is v dash. Okay, so we can directly calculate. This is the v dash. Okay, this vector is v dash, guys. Okay, this vector is v dash here. Sorry, not v dash. This vector is v dash. Now, from the parallelogram theorem, you can check. Okay, we can calculate. We can calculate the result of this. Okay, we can calculate the result of this resultant. Okay, and that resultant is v dash. Okay, that will comes v dash. Okay, that will comes v dash. So is it okay, guys? Now we know. So the magnitude of this v dash will be simply the magnitude. We can find out the magnitude will be v square plus v naught square plus 2 v naught cos theta. Okay, now we are not using v, we are using minus v naught. So wherever v, we will convert into minus sign. Okay, so here minus v, here minus v. Okay, now and theta is equals to 60 degree. So here v square plus v naught square minus v naught equals v naught square minus 2v v naught and cos 60, that is equals to 1 by 2. Okay, cos 60 will comes out to be the value of cos 60, that is 1 by 2. And when you solve these problems, guys, what happen here, v is given already, that is 15. Okay, guys, and v naught is given 30 and minus 2, here 2 is cancelled from here, so here 15 into 30. When you solve this, guys, then you will get the magnitude of this, that will be is equals to, now guys the v dash will equals to, will comes out to be approx 40, okay, kilometer per hour. Is it okay, guys? Is it okay? Now we have to calculate the direction of these vectors. Okay, when you extend in this direction, okay, so it will make the, okay, it will make the angle phi dash. Okay, it will make the angle phi dash from the equator. So we have to calculate phi dash. So this is the phi dash, again this value, again from geometrical properties, this angle also phi dash. Okay, or this is the v vector, again this is the v vector, same vector for, or if I talk, this is the OAB. If I took the triangular sine rule in the, okay, if I talk sine rule in triangle OAB, okay, sine rule, that will be, okay, this is the v, not v dash, this is the v. Okay, this is the, look at this, guys, this is the triangle, we apply sine rule. Okay, what is sine rule? If you, this is the phi dash angle. Okay, guys, so if I take v, then the angle will be the in front of this side, so v upon sine phi dash. And for the resultant, this angle will be, okay, Okay. So for the resultant that is equals to V dash. So look at this, guys. This is the V dash vector, and we have to find out this angle. So look at this, guys. This is V vector. This is the same. Okay, the direction of this V dash vector in this direction. Okay, in this direction. And we know the direction of V dash, that is 60 degree. Okay, so this angle will be pi minus 60 degree. Okay, so sine that angle will be pi minus, or we can say 60 degree. We can write down in radian, that will be equals to pi by 3. Okay, guys, so we know, okay, so we can say this is the sine phi, or it will comes out to v dash upon sine 2 minus, or we can say this will comes out to be minus sine pi, sorry, in second quadrant sine uh, pi 2 pi by 3, pi minus pi by 3, 2 pi by 3. So in sine, in second quadrant sine will be positive. Is it okay, guys? So now we have to calculate sine phi. Okay, sine phi is equals to v dash upon sine v dash upon v naught into sine 2 pi by 3. Okay, guys, so again sine phi v dash we know, v dash the value of v dash that is also given here. Note v dash the value of v, that is 15. Okay, the value of v, that is 15. Or here v dash we already calculated 14, or sin to pi we can know pi by 3, that is equals to root 3 by 2. Okay, when you solve this you will get phi, that is approximately, guys, you can, when you calculate this angle, phi dash will come to here, not phi dash, guys. Okay, phi dash will comes out to be approximate 90 degree, guys. Is it okay, guys? So Erodo is very good problems, guys. Actually, if you have understanding concept, if you have depth knowledge, then you can solve this. Otherwise, it is very difficult to solve the problems. So this is the last question of this lecture. Okay, guys. So it is very, again you have to use some concepts. Otherwise, very difficult. So now, two swimmers leave point A on the bank of river to reach the point B, lying right across on the other bank, and one of them crosses the river along the straight line AB. Okay, while the other swims at a right angle to the streams. Okay, then walks the distance that he has been carried away by the stream to get a point B. What was the velocity of you who is walking if both swimmers reaches the destination simultaneously? The stream velocity we know is 2 km, and the velocity v dash of each swimmer with respect to water is equals to 2.5 meter per second. So what is happening, guys? Look at this very carefully. Okay, in first case, what is happening? So look at this, guys. This is the river. Okay, this is the river. One guy starts. Okay, from it reaches from A to B. Okay, this is the width of the river. Okay, this is the width of the river. This is the point A. This is the point B. So first guy, he reaches from point B. Only in one case he reaches if he swims in this direction. Okay, then he can reaches here. Okay, and this is the stream velocity already given. Then the resultant velocity in this direction. Okay, sorry guys. Then the resultant velocity in this direction. Is it okay, guys? So now this is the V dash, or this is V naught. So now this will automatically, from Pythagoras theorem, V dash square minus V naught square. Okay, the relative velocity. And so sorry guys, this is the distance. Don't confuse with us. This is the width of this river. This is width of this river. Is it okay? That is D. Okay. Okay, that is the. So the time taken, that will be t1. I am assuming t1, that will be equals to t upon distance upon the velocity of the swimmer. That will be v dash square minus v naught square. This is equation 1, guys. Okay, this is the equation 1, or we can say, we can write down here. Okay, t1 is equals to d upon v dash square minus v naught square. This is the equation 1. Is it okay, guys? Now in case second, in second case, what happen? In second case, what happen, guys? See, guys, look at this very carefully. This is the river. This is the river. Okay, guys, and this is the point A here. This is the point B here. Okay, so this is the point A. This is the point B, and the distance that is equals to D. Now, in the previous, that is shortest pass, and this is the quickest pass. Now, the swimmer will start swim in this direction. Okay, in this direction, and the free stream velocity in this direction. Okay, and the resultant velocity in this direction, guys. Okay, the resultant velocity in this direction. Okay, so this is the stream v naught v dash, this is the v naught, and that this is free stream velocity. Okay, guys, now he reaches at this point. Okay, I'm saying this point is b dash c, this point is c dash. Now again he is coming some velocity, this is the drift x, and he's coming with some velocity, we can say this is the velocity u. Okay, and reaches point b. So from here to here. Okay, so this is the velocity and this is the distance. So I am assuming to cover the distance from A to B, he is taking time t2. Okay, he is taking time t2. Okay, so from he reaches A to B here, he crosses the river from time t2. So that time is t2 will be is equals to distance upon his velocity. Okay, his velocity, he is going in this the velocity of swimmer in this direction. So in vertical direction, to cover the vertical distance, that will be d upon v dash. Okay, and again in horizontal direction. Okay, he reaches here. Okay, so he cover this x direction also. So x is equals to, that is horizontal velocity v naught into same time t2. Okay, I replace t2 value here, so x will comes out to be v dash d upon, sorry, v naught d upon v dash. This is the value of x. Now what is happening, another, he reaches here point c, again he will come here c to b. So again t3 time t3, that is to cover the distance cb. So the distance cb is x, and the velocity will be u. Is it okay, guys? And now we can write down simply, that is x is equals to v naught d upon v dash, that is x upon u. Is it okay, guys? Is it okay? Now we have to make relation between t2 and t3. So t2 time from A to C and t3 time C to B, he reaches point B. So we can, from this is the swimmer 2, so swimmer 1. Okay, this is the swimmer 2. Okay, guys. Okay, this is the swimmer 2. Okay, guys, this is the swimmer 2. So now the time taken by swimmer 1, time by swimmer 1 will be equals to time taken by swimmer 2. So time taken by swimmer 1, that is t1, and the time taken by swimmer 2, that is t2 plus t3. It is very important relation, guys. If you able to make this relation, you can easily solve. Now t1 we have already calculated. Okay, that is d upon under root v dash square minus v naught square, and t2 d upon v dash plus t3, that is equals to v naught d upon v dash u. Is it okay, guys? Is it okay? Now, guys, when you further solve it up, if I am taking the common from v dash square minus v naught square, I am taking d, v dash here is common. That is 1 plus v naught upon u. Is it okay, guys? Here d as it is cancelled. Now, I am writing here, if I take v dash here and if I, okay, square, we will square, so v dash square upon, and this will terms will square. Okay, guys, and this will also, sorry guys, what, and we will not do square, we can directly solve because we have to calculate the value of e naught. Okay, so what, see guys, here, and when you solve further, so see, v dash will come here. Okay, and the denominator will be v dash square minus v naught square, that will be equals to 1 plus v naught upon u. Now we have to calculate u. So guys, look at this very carefully, in this expression. So 1 second. Okay, we are taking v naught upon u. Okay, so here v dash upon, again I am taking v dash common here. So here v minus v naught square upon v dash square. Is it okay, guys? Or this minus 1 come here. Here v dash is v dash cancel. So now we can easily calculate the value of u. Okay, guys? So look at this. We want to calculate the value of stream velocity. Okay, so look at this expression very carefully. I'm taking u is equals to v naught upon. Okay, so look at this, guys. I'm writing this portion in this way. Okay, under root 1 minus v naught square upon v dash square. This power minus 1. Okay, and this power minus. Oh, sorry, this is minus 1. Is it okay, guys? Now we know the value of v naught. Okay, when we further solve it, we know the value of v naught. Okay, guys, and the value of v naught, that is equals to 2 meter per second. Okay, 2 kilometer per hour, and the value of the v naught square upon v dash square, that is 2 upon 2.5 whole square. Is it okay, guys? Is it okay? And that is minus 1. Okay, and the whole power is equals to minus 1. When you guys solve this, okay, we solve this is for outside under root 1 minus. So when you solve this will comes out 20 by 15, 20 upon 25. Okay, when divided by 5, this will comes out to 4 by 5. Okay, when you square 4 by 5, so 16 divided by 25. When you solve this will comes out to be 3 by 5, because 25 minus 16, 9 by 25, that will 3 by 5. And the inverse of 3 by 5, that is equals to 5 by 3. Okay, the inverse of 3 5, that equals to 5 by 3. Okay, so here 2 upon 5 by 3 minus 1. When you solve this will comes out to be 3 kilometer per hour. So is it okay, guys? Okay, so this is our first lecture of Erodo series. Here we discussed our first two seventh problem. Okay, guys, now for any more courses, for further courses, you can join our live classes on this our value as a point. You can download our app from Google Play Store or iStore. Okay, you can visit our website regularly for new updates. Okay, you can purchase our course and you can start your preparations so that you can complete your dream along with your 12th standards. Thank you so much. Thank you. Bye bye.